A slightly easier form of evaluation than the cognitive walkthrough, although one which requires a little more sophistication on the part of the evaluator, is Jacob Nielsen and Rolf Mollick's heuristic evaluation. How this works basically is to give you a list of 10 heuristics which you apply to a website or a piece of software. The idea being you try to analyze whether these heuristics, or if you like guidelines, are upheld or transgressed. And in doing this, you can then establish your usability critique. Now, in some ways, it is easier than the cognitive walkthrough, namely you just have to identify examples of transgression or upholding of the heuristics. On the other hand, it does require you to train your eye to be able to recognize instances of the various guidelines in order to be able to use it well, whereas the cognitive walkthrough is much more prescriptive. You are given very strict methods where you establish who the users are, what the task is, what are the actions required to do the task, and then applying the 4 questions to each of these actions. And so therefore, you don't really have to exercise so much of an interpretative ability, whereas with heuristic evaluation you do have some real requirement of interpretation. Anyway, so let's go through them and just explain all the various individual instances and examples of them. The first heuristic is called visibility of system status, and by this is meant the system should always keep users informed about what is going on through appropriate feedback in reasonable time. Examples of this will be, for example, the download percentage box when you've downloaded a file, for example, off the internet, or the dialogue where you see a kind of file being animated going into a folder that you have when doing sort of long saving operations on Windows. Others examples might be, for example, the hourglass cursor, indicating that the system is not usable. It is undertaking some sort of operation which requires a lot of time. Other maybe less obvious things might be, for example, systems which have various states, and it tells you which state you might be in. For example, a website, you have various pages that you can navigate to, and it's difficult to know whether something like the actual position of where you are within a website is truly visibility of system status, although you can certainly argue that that is the case. As we will see as we progress through the heuristics, you'll find that there are a number of phenomena within software development and website development which can fall into more than one heuristic, and I'll explain them. So, just summing up, there are the really good examples of visibility of system status are things like the hourglass cursor, which indicates that the system is not usable at that time, the percentage downloaded in the save dialog, and for example, the status bar of Internet Explorer when you're at a page which is it's just kind of putting all the elements into place on the page of the loading page status bar. These are all examples of visibility of system status. The next important heuristic is match between the system and the real world. Okay, so this means the system should speak the user's language with words, phrases and concepts similar to the user. So, for example, examples we can have, for example, of a bad use of the system in the real world is in the DOS prompt when you fail to format a disk. For example, it says disk not formatted, trial, retry, abort. Retry and abort are not very friendly language, not what particular ones the user would like. Another example, as was pointed out during the lecture, is things like in the add remove programs dialog within the control panel of Windows, there is the line populating list of installed programs. Populating is a very kind of technical verb, which it might be better just saying creating the list of installed programs, or ultimately by using the word populating, you're thinking in the way of a programmer. You have established the empty structure with which you are going to fill with data, but of course this is not how the user sees it. So you would be just creating the list would be probably better, or typing out the list of installed programs might be a better example. So just summarizing, for example, on Unix machines you often get sort of programs like VI or Emacs, the text editing programs. They often have the bizarre status phrase writing buffer to disk, to indicate that they are saving what you have written into a file, whereas obviously saving file is a much better way of expressing that. Things like in DOS dialogues, try again and cancel would be much better than retry and abort. So that's heuristic number 2. Okay, but as I say, there are occasions where a particular phenomenon doesn't necessarily fall ideally into one heuristic or another. Match between system and the real world is one heuristic, but there's one later on which is about error messages, and in that one you can imagine the try again cancel as opposed to retry and abort would be valid within that heuristic as well. So the third heuristic is user control and freedom. Okay, so users will often do things by mistake and will need clearly marked emergency exits to leave the unwanted state quickly. Okay, good examples would be, for example, you've kind of navigated down a very long website and you want to be able to get back to one of the pages you traversed on the way. The easiest way will be potentially to go back to the home page in order to allow you to retrace your steps. Similarly, you might the back button and the forward button within the web browser is particularly geared to upholding this heuristic, namely of allowing you control and freedom. If you've accidentally navigated to a page you didn't want to, you click back, you get immediately back to where you came from. The undo and redo buttons also are very much about allowing you user control and freedom. Okay, you made a mistake and that just allows you to get back to the previous state. Do you really want to delete dialogues could also be said to be user control and freedom. There's also could be said to be preventing error. Okay, and another one is for example, pressing Control-C, Control-V, or using accelerator keys. Is that user control and freedom? In some ways it is, but potentially there is a better heuristic to describe that particular one. Heuristic number 4 is consistency and standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. You should follow platform conventions. So therefore, things like really bad kind of uses of avoiding of consistency and standards will be things like having highlighted blue text in a web page to indicate emphasis, when typically blue text in a web page indicates clickability. Okay, and things like rollovers indicates something that can be clicked. If that was not used for that purpose, that would also be a big consistency and standards violation. Okay, so here's as I summing up: blue text and underline on differently coloured text for hyperlink on a web page. That is a standard which you should follow. Okay, cursor changes to the hand when an object becomes clickable. These are obvious standards, and there's no point in transgressing them. Error prevention. Okay, better than good error message is a careful design preventing errors happening. If, for example, you have a very important key which performs a particular operation, or a particular button which performs a particular operation, it's probably not a good idea to have it near another button which performs a very different one. So for example, having an add and a delete button for rows in a table, in a database for example, would be slightly absurd, because if you accidentally hit the wrong one you could cause an error. So therefore error prevention is a very important heuristic. And examples that you can think of are graying out menu and button options when you shouldn't really use them, always warning a user before deletion. So, and I think that is true, that it falls more in this heuristic of error prevention, warning a user before deletion, rather than in user control and freedom. Okay, although it has similarities to it. Also, don't place buttons which do deletion or cancelling operations near to buttons which do saving ones. That's another good example. Recognition rather than recall. Make objects, actions and options visible. A user should not have to remember information from one part of a dialogue to another. Typically this is now almost second nature amongst most developers. It's very, very primitive applications where you have to remember codes seen on one screen to perform an operation on those things in another screen. This certainly was the case in earlier software, but now in Windows it's very difficult to actually see any examples of people just doing such obvious violations of that heuristic. However, there can be more subtle ones, namely that important options being squirreled away too far down a menu tree to be, recognizable by users. They have to be remembered where they are. Things like important information on websites being accessible only from certain pages and without a real understanding of the user of how to get to that important information. So the good, canonical examples of what you should avoid are things like use menus rather than command codes. Use tooltips to indicate the meaning of buttons. This is a good example. If a button has an icon on it, if the icon is absolutely clear and well known, that won't be a problem. If it is, if you can put a tooltip with that button, then should there be any ambiguity there, the user will be able to work it out. Another example, use wizards for complex selections by the user, where the user is kind of almost asked questions. Do you want this? Do you want that? Because in certain cases, certain selections are dependent on prior selections. So that is the case where recognition is better than recall. Flexibility and efficiency of use. This is heuristic number 7, and this means using accelerated methods for doing common tasks. Okay, so I mean, it's similar to the other heuristic, user control and freedom. Okay, but that user control and freedom is more about allowing the user to get out of unwanted states. Flexibility and efficiency of use, however, is much more about speeding up common tasks. So therefore the most obvious things are buttons with icons instead of menus, or indeed accelerator keys instead of buttons. So Control-C, Control-V for copying and pasting, Alt-F4 for closing down the window, things like that. That is what is meant by flexibility and efficiency of use. Okay, as I say, so the printer icon for printing, Control-C and Control-V for copying and pasting. These are good examples of flexibility and efficiency of use. Aesthetic and minimalist design. Dialogue should not contain information which is irrelevant or rarely needed. By this is meant to try and avoid having information which has kind of like a very specific purpose, or very small kind of importance within the overall functioning of the application, together with very important ones. Okay, one of the most common example I have of this is the customized dialogue within Microsoft Word, or the options, I can't remember. But anyway, one of these ones has so many options that you can change that it rapidly becomes very, very bewildering. Some of them might be hugely important and some of them not so important at all. Another example of an operation within software where we get this mixture of highly important information together with lots and lots of much more peripheral and rarely needed information is in something like the configuration files for web servers like Apache, where you have enormous amounts of configuration information, a lot of it very, very important, and some of it, very minor importance, which might be better if the files were actually subdivided into smaller files with more obvious functional purpose. Okay. So the ways we can sometimes get round this problem of huge numbers of options to be set might be tabbed boxes in preferences dialogues, and one kind of not completely successful but worthy attempt at resolving this issue is the concept of extendable menus within Windows XP. Typically in Windows XP, if a menu item has not been used very much recently, it doesn't actually appear on the menu, and you have these double arrows on the menu which allow you to fully pull down the menu, so that ideally only the most important or the most important ones to you will be shown. Unfortunately, this can be quite irritating, especially if something as common as doing new within the file menu or doing open within the file menu should be hidden, largely because you haven't used it for a while. You've kind of either double clicked on doc files or kind of gone to the kind of last 4 files done to actually open files, never really used the new or the open, and suddenly the new or the open disappear. And this is obviously quite a big problem. But anyway, that is always going to be an issue in any kind of software development, is how much is made visible to the user, because as you remember from the lectures of Donald Norman's The Design of Everyday Things, absolute visibility is certainly the easiest, where everything is available on the surface, but if there are too many things available, then it becomes disorienting. Number 9. Help users recognize, diagnose and recover from errors. Messages should be explained in plain language without the use of codes. Precisely indicate the problem and suggest a solution. So this is again similar to heuristic number 2, which was speak the user's language. Speak the user's language, though, is more specifically based on, speak the user's language match between system and the real world, is more on following the conventions of the world and the ways things should be understood in the general functioning of the program. However, this is more about those occasions when errors do occur, to actually offer an explanation of the error which a non-technical person will be able to understand, and moreover would point them to the solution to this problem. Okay, so that is heuristic number 9. The final heuristic is help and documentation. I mean, all information should be easy to search, focused on the user's task. You should list the concrete steps to be carried out, and it should not be too long. Okay, so that's that question of searchability is crucial in help documentation, because very often it's a very specific thing we want to find out how to do. We don't necessarily want an overview. We don't necessarily need to know the logic of how an application works. Just know a very specific how to do this. So therefore, the searchability in terms of language is very important. Should be focused on the user's task. So typically you would have sections within the help documentation which would have overviews to actually represent specific kind of task configurations which the user might easily be able to get to, and should list concrete steps to be carried out. Okay, an example of bad documentation would be, for example, I remember, say around about 2002, Cubase VST had documentation which is entirely based on the file, on the menu structure. So you'd have all the menus, so you'd have file, open, save, save as, and all their dialog boxes would be based on that. So therefore you would have all your documentation would be based on either the menus or the dialog boxes. The problem being typically is, if I want to know how to do something I don't know how to do, just giving me the list of all the available functionality within the application is not going to help me, because I basically don't know where to look in the first place. Okay, so it would be much better if the whole thing was then searchable by terms of tasks, in terms of concepts. Then it makes it much easier for me to get to the really important information that I want to find. Anyway, so those are the 10 heuristics of Jacob Nielsen and Rolf Molich. A really stupendous book for you to read would be Usability Engineering, and this would be this is written by Jacob Nielsen. It has a lot of his writings about usability, and it's a superb book, and just by reading that you'd basically learn virtually everything you need to know about usability evaluation.